Hi, in this video we'll discuss on Newton's law of gravity. Okay, it is very surprising that our day-to-day life experienced phenomena which are related to falling object towards the earth, like an apple falling from a tree, rain falling, and so on, and astronomical phenomena like moon orbiting around the earth, and a galaxy can hold a billions of stars, and so on. All these phenomena have the same reason, the gravitational force, which is the weakest force among four fundamental forces exist in nature. Okay. All these phenomena can also be explained by Einstein's general theory of relativity, where he talked about the structure of space-time in presence of massive objects. However, Newton first introduced gravity in 1687 by publishing a remarkable law of nature in his book Principia Mathematica. Okay. Where he said that every point mass attracts every other point mass, okay, with a force that is proportional to their masses and inversely proportional to the square of the distance between them. Let's say two point masses m1 and m2 separated by a distance r. Okay, so the magnitude of the force between them is proportional to mass of them, that is m1 and m2. Okay, and inversely proportional to the distance square, that is r square. Okay, so we can express it as F equal to g times m1 m2 by r square, where g is the proportionality constant which is known as gravitational constant. Okay, the value of g was first determined by Henry Cavendish, which is very close to the current value, that is approximately g equal to 6.674 into 10 to the power minus 11 in SI unit. Okay, to find out the unit, we may express g as this way. So in SI unit, the unit of g will be the unit of force in SI unit, that is Newton, times the unit of distance square, that is meter square, by unit of mass square. So that would be kg to the power minus 2. Okay. Now let's talk about the direction of the force. Okay. Gravitational force is an attractive force. That means m1 attracts m2 and m2 also attracts m1. Okay, so the force on m1 due to m2 will be in this direction, right? So r2 be the position vector of m2 mass and r1 be the position vector of m1 mass, then r vector will be r2 vector minus r1 vector, right? So r2 vector minus r1 vector. Okay, so the force acting on particle 1 due to particle 2, that is F12, will be G into m1 m2 by r square into r hat, right? Where r hat is the unit vector along r vector. The force acting on m2 due to the mass m1 will be exactly opposite direction to the F12, right? So F21, that is force acting on particle 2 due to particle 1, that is F21 equal to minus of F12, right? Let's take an example. Calculate the gravitational force between two balls having mass 8 kg and 6 kg separated by a distance 20 centimeter. Okay. Let's say M1 equal to 8 kg and M2 equal to 6 kg. Okay, and distance between them, that is r equal to 20 centimeter, so that is equal to 0.2 meter. Okay, let's draw a diagram for it. This is m1 and this is m2, and distance between them is r. Okay, so the force will be g m1 m2 by r square. Okay, if we put the value of this thing, that is the value of g is 6.674 into 10 to the power minus 11, and value of m1 is 8 kg and value of m2 is 6 kg, over the r is 0.2 square. Okay, so that will give you 8 into 10 to the power minus 8 Newton. Okay, so the two balls attract each other with this force. Okay, this is a very weak force, but how weak it is, you may realize if you hold a 102-gram ball and due to Earth's gravity, it will be pulled by 1 Newton force. Okay, now you must have realized how weak this force